access to the notes from the times. So this is the file I'm going to use. It's about measurement technique. Okay, let me go to the, okay. Okay, so this is about measurement technique. This topic is very useful when you do practical. Okay, when you do practical, and how do you handle with the instruments? Okay, okay. Let's say, for example, when you use ruler, when you read the reading, let's say the reading is 10 centimeter length. Okay, okay, the length is 10 centimeter. How do you write it? You put 10, 10 cm, or you put 10.0 cm, or you can put 10.00 cm. That matters. Okay, so how to write, how many decimal to write? That's what we're going to learn here under this technique. Okay, the first we're going to discuss is about how to do measurements. So all type of instrument which is quite familiar for you last time, we're going to recall back. Okay, the first, these are the instruments which you already know before. We just recall back how to use it. So length, you measure what? Length you use by using, of course, ruler, vernier caliper, and micrometer screw gauge. I know micrometer screw gauge is a more precise instrument to measure diameter. To measure a length within 15 centimeter, you go for vernier caliper. Ruler for a normal length. Volume, you can go for measuring cylinder, angle protector, and mass, use spring balance, lever balance, and electronic balance. Normally we go for electronic balance, more digital. And time stopwatch, or we use cathode oscilloscope. I think your A levels be more to stopwatch. And temperature, of course, thermometer and electrical equipments like ammeter, voltmeter, galvanometer are used. Okay, first, how do you use ruler? Okay, ruler. Okay, this is some rule for you to follow. Okay, so ruler measure the length. Let me take the annotation. Sorry. Okay, so the ruler is used to measure the length, 1 meter. Okay, the accuracy of the ruler is 0.1 cm. Accuracy of the ruler is 0.1 cm. And accuracy of the pointer is 0.05 cm. Okay, see, this is the rule for you to follow. The rule is, missed out the annotation. Okay, the rule, when you write a reading by using a ruler, how many decimal to write? So it depends to the scale. Okay, the scale, how many decimal you need to write, it depends to the uncertainty in the scale. Uncertainty in the scale, the plus minus, you write length is 10 centimeter, plus minus how much? That's called uncertainty. The uncertainty is always go for half of the smaller scale. What is that? Half of the smaller scale is your uncertainty. It determines the number of decimal to be used. Okay, for ruler, what is the half of the smaller scale? What is the smaller scale of a ruler? I think you have a ruler with you. So what is the smaller scale of your ruler? Anyone? So the scale of the ruler is 0.1 cm, right? 0.1 cm. So half of the 0.1 cm is how much?
0.05.
0.05.
Very good, 0.05. So when you read a reading from a ruler, the reading you must write in 2 decimal places because the uncertainty is 0.05. You see the picture here, the pointer reading here on your left, on your right, the pointer reading, they written as 22.05. Why they go for 2 decimal places? Because the error, the uncertainty is, the rule is half of the smaller scale. Okay, so that's why on top here, you see the reading on top here. On the top there, the accuracy is 0.1 cm. The accuracy is 0.1, smaller scale. The pointer reading is 0.05, half of the smaller scale. Okay, now you see the diagram on the left. On a ruler with a coarse scale, the rod is 3 to 4 cm was placed on the ruler side. Okay, it's 3.3 centimeter. It's 3.3 centimeter. When you measure this length, you take reading how many places? You take reading how many places? You read the the maximum value, which is 3 point something. And also you have another reading, which we take for granted, the zero, the,
Oh,
zero, the left side. We take for granted. We think that we perfectly place the ruler 0 at the end, but in reality there might be some error over there. So how many readings you take to measure the length? Actually, 2 places, uncertain. Okay, so that, let's say the reading is there is 3.3 centimeter, 3.3 centimeter. You're supposed to write what? Because half of the smaller scale is how much? 0.05, right? So you're supposed to write 3.30 centimeter, right? Because you are 2 places uncertain, the 0 and 3.3, the error will be added. The error will be added because 2 places uncertain. One error how much? 0.05. Another error how much? Another 0.05. So total error how much? 0.0, 0.1. It becomes 0.1. Yeah. So when you have 2 places uncertain, the error both sides add up becomes 0.1. So in that case, the reading, if you have 3.3 centimeter, you don't write 3.30 centimeter. You just write 3.3 centimeter. Why? The decimal place is determined by what? The error. Okay, the uncertainty. In this case, the uncertainty got how many places? 2 places. If 2 places got uncertainty, you add them. So 0.05 becomes 0.1. So your final answer for the length, you just write 3.3. Okay, that's why on the left diagram, the ruler is written as 3.3 centimeter. Okay. So what you learn from here? This slide. 2 way of writing the reading. One is a pointer reading. On the right is a pointer reading. Just read the scale. 22.05. Just pointer reading means only one place uncertain. If you want to measure the length, how many places you uncertain? 2 places uncertain. 0.05 plus 0.05 becomes 0.1. So reading you measure must go for 1 decimal place only. Clear? So why 1 decimal place? Because error is 1 decimal place, 0.1. Okay, so that's why we wrote 3.3. Okay. Okay, this is a normal way of course, you practice that in your early studies from 5. How do you read ruler? Try to read at a scale at eye level. Okay. Try to avoid parallax error. Okay, of course. Make sure the end ruler and end errors of the ruler, make sure it's exactly placed at 0. Poor alignment with the error. Make sure the poor alignment, the ruler and the object you want to measure must be perfectly vertical. Don't put the ruler a little diagonal. These are the methods you have to use when you use ruler. Okay, as I told you, this topic is for what? This topic to use for practical. How do you use the instruments? How do you write the scale? Okay. Okay. So I believe you have come across with this instrument, vernier caliper. Okay. Vernier caliper is better than ruler because of what? It's more precise instrument. More precise instrument. How much of decimal place you can give in centimeter? 2 decimal places. You can give 0.01 cm. Okay. A student measure length of his handphone, the width of his handphone, by using a vernier caliper, and he wrote the reading as 5.0 centimeter. Is it correct or wrong? It's wrong. How we can write 5.0 centimeter? If you write 5.0 centimeter, what the examiners, the scientists will think you used ruler. Okay, a ruler means 1 decimal place, right? 5.0 ruler. If you use vernier caliper, how are you supposed to write the length? 5.00. So vernier caliper, when you use a vernier caliper, make sure you write 2 decimal place in centimeter. Okay. So now you see you have 2 scales to read on the top. The vernier scale, laboratory, vernier caliper allows a more accurate reading compared to the meter rule. Okay. So the main scale is as a maximum of normally 15 centimeter range normally. And vernier scale normally will have 10 divisions, but some vernier caliper can go up to 50 divisions. I want your feedback. Your Form 5, your O-level studies, the vernier caliper, I believe you have used it before. The vernier scale got how many what do you call divisions? 10 or 50? Can you remember? At the bottom, you see at the bottom, this is called vernier scale. Number 6 is the vernier scale. The vernier scale, you got the division, you got how many? 10 divisions. This one in the diagram here, number 6, got how many divisions? This one got 20 divisions. 0 to, you see 0 to 1 itself got 2 divisions. Okay. The one you used in your school is how much? 10 divisions. Can you remember? Can't remember. I think most probably 10 divisions. But what I'm trying to tell you here, you might have a vernier scale with more divisions down here. Okay, more divisions is down here. Whatever divisions you have here, this entire divisions is, for example, you see here number 2 on top, vernier scale is 50 divisions. That means the vernier scale got 50 divisions. That means 0 to 1 itself, you have five lines in between. 0 to 1 itself, down here the vernier scale, you have 5 lines. That means 0 to 10, you have how many lines? 50 divisions. The 50 divisions equals to what length? Vernier scale. What length? 0.1 cm. 0.1 cm. That means one division how much? 0.002 cm. Okay. This is another kind of vernier scale. In Taylor's later, when you go to the actual lab, I think most probably you're going to see this kind of a vernier caliper. With bottom, how many division you will have? 50. You'll have 50. Okay, suddenly the annotate is missing. Where's the annotate? Okay. Okay, so this is this is good. This is the digital one. Actually, we are proposing to the Taylor's College to get a digital one. If digital, you straight away can read it. Okay. Okay, you see this in this diagram here. Okay. They are main scale, they are vernier scale. This vernier scale, how many division it has? How many division it has? 10 division. Right? Main scale, the vernier scale, you got the smaller one on the right. It's a vernier scale. So how many division you have? 10 division. Okay. 10 division equals to how many centimeter? The one small division in the main scale. What is the one small scale in the main scale? 0.1. 0.1. So vernier scale, one division of should be how much? 0.1 divided by 10. Okay, 0.1 divided by 10. So the vernier scale, one reading will be how much?
0.01.
0.01. Okay, in this diagram, what is the reading? I see the reading. The main scale reading is how much?
756.5.
Okay, we put it in centimeter first. This was in millimeter. Okay, right in centimeter. Main scale centimeter reading is how much? You read before 0. Main scale you read before 0. So it's 75.6, correct? In centimeter. Everyone agree? You read before 0. Read before 0. The main scale, you read before 0 at the bottom.
75.6.
75.6. Don't read 75.7. Wrong. Read the reading before the 0 at the vernier scale. The main reading is 75.6. Okay. Then need to plus with the vernier scale. Vernier scale how much? How do you see the vernier scale? Recall back your early studies. How do you find the vernier scale? We check which line is parallel, right?
Yes.
Which line is parallel in this case?
5.
1, 2, 3, 4, 5. Yeah, 5 is looks parallel to the above scale. So the main scale reading is pi. One vernier scale, how much? 0.01. So it should be 0.05. So altogether 75.6 plus 0.05. So answer is 75.65 centimeter. I'm just doing what you learned last time. The answer given here is in millimeter, right? Okay, so you need to know how to read this. This vernier is a primitive one. Why I say primitive? Because the vernier scale only got 10. What I've told you, when you come back to tailors, you're going to see 50 here. Okay, like next slide. Okay, this slide also vernier. Okay, you see the diagram. What is the main scale reading? Anyone? Vernier scale got how much? How many division?
10.
Vernier scale got 10. Each vernier scale, what is the reading? 0.1
0.01.
10, so 0.01. Okay. So step one, when you use the vernier scale, check for zero error first. Is there any zero error or not? When without object, you just close it. Make sure the zero on top and zero at the bottom is aligned. If it's not aligned, that means it has a zero error. Okay, we will do that zero error later. Okay, so first, next step, you need to read the step two. Step two, open the jaws, grip the object. Okay, make sure the object is gripped. Then step three, what do you do? Read main scale opposite to the zero mark and vernier scale. Main scale reading is 2.1. You agree main scale is 2.1? Read before zero.
Yes.
The above 2.1. Cannot read 2.2 before zero. The main scale is 2.1. Vernier scale how much? Vernier scale 1, 2, 3, like 4. 4 is like quite parallel. 5 also quite parallel. If any student put 5, you won't be wrong. One slightly different is fine, but it looks like 4 is quite good. So the vernier scale reading is 0.04. Altogether end up getting 2.14 cm and 2.14 cm. This is recall back how do you use. So this again vernier caliper or old type with 10 division. So read the main scale, read the vernier scale, add them. But before you use this, check for zero error. Okay. Okay. So now your turn. Okay. Now you are given. This is the new one. Okay. Please check from this vernier diagram. What is the main scale reading?
3.7.
Yes, it's 3.7. The main scale reading is 3.7. Unit is centimeter. So main scale is 3.7 centimeter. Okay. Vernier scale. This is vernier scale. Got how many divisions are there? Got 50 divisions. You see, you got 50 divisions. From 0 to 1 itself, we got 5 divisions. 0 to 10, you got 50 divisions. So each division reading how much?
0.02.
Very good. 0.02 cm. Sorry, 0.02 mm. Sorry, right? 0.02 mm. 0.1 cm divided by 5 is 0.02. 0.1 cm divided by 5. How much you get? 0.02 cm. Okay, 0.02 cm. Oh, yeah, sorry. 0.1 divided by 50. 0.1 centimeter divided by 50, you get 0.02 mm. Okay, so your main reading is 3.7 or 3 to 3.8 centimeter. Your vernier reading is 0.46 mm. Okay, 0.46 mm. Yeah, 0.46 mm. 0.1 cm, 0.46. So finally, what do you get? You get
3.746 cm.
yeah, 0.7. Okay. You want to put in centimeter, can? If you want to put centimeter, how much vernier scale you put?
0.00.
0.0.
As usual, if it's exactly 4, you write 0.04 cm, right? 0.04 cm. If you get the third scale is in parallel, so this is going to be 0.4. Sorry, 0.046. 0.046 centimeter. 0.046 centimeter. So 3.7 centimeter plus 0.046 centimeter, you get final answer. 3.746 centimeter. So 4 means 0.04. Any additional short scale, you're going to be 0.042 first one, 0.044 second one, 0.046 third one, 0.048 fifth one, then finally 0.05. Then 0.052, all in centimeter. This is the vernier caliper you're going to expose and come to tell us later. 50 divisions in the vernier caliper, in the vernier scale. Okay, let's see how well you can proceed with this. I go to the another one. Get the reading. What's the main reading? Main reading is 3 or 3.1. You put it in centimeter. Main reading 3 centimeter or 3.1 centimeter. Read before 0.
3. 3. 3. 3.
Okay, your vernier scale. Vernier scale. Check which is parallel. This is not parallel. This is not parallel. Which one is parallel?
9.
9. 9. Yeah, 9 looks parallel. Exactly line. So 0.090 you're supposed to write. Okay. So that's your main scale. So then the vernier scale is exactly 0.090. And the final answer is this one. 3.090. SPM you wrote 3.09 cm. You've got 10 division in vernier. If you've got 50 division in vernier, you must write 3.090. 3 decimal places. Okay, 3 decimal places. The smaller scale in the vernier determines the decimal place here. Okay. Any questions from this slide before we proceed? So you get the main scale reading before 0 and the vernier scale, check which is parallel. If you got 50 divisions, then you must write 3 decimal place in centimeter. Why 3 decimal place? Because uncertainty in the vernier follows the smaller scale. Actually, half of the smaller scale is the rule. But in the vernier, you 2 places uncertain. Where do you 2 places uncertain? How many times you read the vernier scale? How many times you read the vernier scale? The main scale and the vernier scale one. How many times you read? Twice, right?
2 times.
Twice. Twice you read the vernier, the reading one. So the uncertainty is half of the smaller scale. Half of the smaller scale, half of the smaller scale become how much? The smallest scale. Like ruler. That's not the ruler. The pointer reading is half of the smaller scale, 0.05. But you want to measure the length. How many places you uncertain? 2 places uncertain. So 0.05, 0.05 become 0.1, become smaller scale. So when you also the same thing, the uncertainty follows the decimal place of the smaller scale. Why smaller scale? Because half of the smaller scale for twice become smaller scale. They add up. Okay. So 50 division, conclusion, you must write 3 decimal place in centimeter. Okay, let's see how you well cope with this. We go another one, try to get the reading. Okay, this one. Not 1 minute for you. Get the reading in centimeter. How many places you must get? 3 decimal place. What is the main scale reading?
0.7.
0.
0.8.
Around 0.8 lah. 0.8.
Oh, 8.
Yeah, 0.8. Parallel also quite very because it's quite close to 0.8. I think the parallel one will be quite close to 1 to the left. Which one looks parallel? The second interval, second or third interval also accepted. Fourth interval before 1, I think not that. 1 itself is already a little out. I think second one. 0.004 or 0.006 is accepted. So this is your 0.08 or on the top of the diagram. I think better image. 1. Go for 1 lah. Looks like 1 is more clearer. So what's the reading? What's your answer? 0.810 centimeter. You agree?
Yes.
Scale is 0.8. The vernier scale is 0.010. You must put 0 at the back, because 0.02 cm the uncertainty. If vernier scale only got 10 division means, let's say this vernier caliper, the vernier scale only got 10 divisions means how do you write your answer? 0.81 only, right? If you only got 10 division. If you got 50 division, 0.810 centimeter. Cambridge, actually, they don't care is it 0.81 or 0.810. They don't care about the number. They care about the decimal place. Decimal place wrong, straight away you 0 mark. Okay, they check the decimal places. Why? From the decimal place, they get to know what instrument you use, what type of vernier scale are there. Okay. Next, this one. What's your scale reading? What is your vernier reading? 1 minute. Give me in centimeter. Main scale how much?
0.4.
3.4 as vernier. I think you look at the picture on the top. Which one? I think 6 parallel. 6
and
6 centimeter parallel.
0.06 and 0.061 looks close.
Yeah, if you give both, you are not wrong. You get answer. You get correct. They give a range because sometimes human capability. Okay, so let's see. So that's your 3.4. So it's 3.4. So 3.462. Those who go 6, you can write 3.460. Also accepted. Slightly different is fine. Okay. Important is you must write 3 significant figure. All of you write 3 decimal place, not significant figure. 3 decimal place. This data called raw data. Raw data means you get reading from the instrument. So if you get reading from the instrument, it's called raw data. Remember, raw data follow decimal places. What again? This is a keyword. Raw data, when you take reading from the instrument, you must follow what? Decimal place of the instrument. Okay. When you do calculation, like yesterday we did the physical quantity calculation. Some of you asked me how many significant to be used. I told you significant figure. What type of data is that? That is calculated data. In this physics, you have 2 types of data: calculated data, raw data. Raw data you take it from the instrument. You follow what? decimal places. Like for example, ruler. You measure the reading of the ruler. How many decimal places you write? You write 2 decimal places. If you measure, you write 1 decimal place if you use a ruler, because 2 places are uncertain. So the decimal place is determined by the instrument. Vernier caliper, this case, you write 3 decimal places. Okay, so raw data follow decimal place. Calculated data follow significant figure. How many significant figure to be used? What I told you last class, the smallest significant figure among the data used. Okay, A plus B. A is 2 SF, B is 3 SF. The final answer will be how many SF? 2 SF. Okay, follow the 2. Okay, we proceed. Okay, sometimes you will have 0 error. Okay, you will have 0 error. So that's your reading on top. 0 error. So this is 0 error. The first diagram, 0 error, don't have any value. Second one, you have 0 error, like how much? Positive 3. If the okay. If the 0 on top is to the left, if the 0 on top is to the left, okay, then it's a positive 0 error, 0.3. Okay, positive 0.3. Once you identify the 0 error, how do you find 0 error? 0 error, you have to see the Vernier scale. You see in the second diagram, the 3 is parallel without any object in the clamp. So only 3 is in parallel. So 0 error is 0.3 mm. Positive 0.3 mm. Okay. Positive or negative, we check the reading from the bottom, the 0 here. The 0 at bottom is to the right, then it's positive. Okay. The 0 at the bottom to the left, then we say the 0 error is negative 0.2. Okay. So how do you treat with the 0 error? Whatever measurement you got, you must minus the 0 error. Please use this formula. Always minus 0 error. The 0 error itself can be positive, negative. If 0 error is negative, let's say for example negative 0.2, you must put minus in bracket. You must put minus 0.2. Okay, 0 error can be positive, negative. Recall back, you learn this right in your form 5. 0 error. Okay. Okay, that's the second instrument, Vernier caliper. The more precise instrument, of course, the one I'm showing now, micrometer screw gauge. Okay, this one, when do you use this? When do you use this? This you use to measure diameter of wire. Okay. What is the maximum length this micrometer screw MSG? I put it MSG. What is the maximum length you can measure by using MSG? Around 5 centimeter, about 5 centimeter. So whenever they ask you to measure diameter of wire, the best device you can use is MSG, micrometer screw gauge. Okay, don't ever use Vernier caliper. Okay, length for like 8 centimeter, 10 centimeter go Vernier caliper, but diameter of wire, thickness of a paper, thickness of a metal sheet, you go for micrometer. Okay. Okay, so micrometer, I believe everyone have used this before. You have 2 scale again. What is that? You have the main scale. Main scale on the bar, and you have a vernier scale. Vernier scale normally will be 50 divisions. Okay. The main scale you go 1 round. The main scale you go 1 round, it will equivalent to 0.5 mm. So 1 division how much? 0.01 mm. Okay, 0.01 mm. Okay, I don't know why I cannot annotate. I cannot find that annotate. I cannot write it. Okay. Okay, so you can see the whiteboard. You can see, yeah? Okay. So this is your micrometer. So this is your main scale, and this is 0. Okay. Then you got bottom 1, then this is 1. Okay. So you go one round here. When you make one round, okay, the one round equals to when you make one round, about half will come out, will visible when you make one round. That means reading here how much? Reading here would be 0.5 mm. So 0.5 mm equals to how many division? This scale got how many division? 50 division. So one division how much? 0.01 mm. One division is 0.01 mm. Okay. So let's say you put something on the vernier scale on your micrometer. The reading was like this. Okay, this is 0, and here you show 35. Okay, exactly 35. What is your main scale reading? So you read the latest number here. How much is this main scale? This is
1.
2.5. Yeah, this is 1. So 1 mm or 1 cm?
1 mm.
The micrometer read mm. So it's 1 mm. It's 1 mm. No cm in micrometer screw gauge. 1 mm plus. Your main scale 35. 0.0.
35.
Yeah, that's correct. 0.35. So 1.35 lah. 1.35 mm. Sorry. So 2 decimal in mm. Okay. Let me go back to the. You can see the PowerPoint. Okay. Okay. So look at. I don't want to read the entire thing. So look at the diagram at the bottom. What is the reading? The main reading is 2.5. Main reading is 2.5, right? The scale
Yes.
is 0.46, so it's 2.96 mm. Okay. Okay. So look at the diagram above. This is the step 1, step 2, step 3 for you to follow your experiment. First, of course, check for what? Zero error. Check is there any zero error. Okay. So check is there any zero error. So don't put anything, close the what do you call the spindle, then you check is there any zero error. Then second, place the object, read the main reading. What is the main reading for this case? We follow the last diagram here. Main reading is 2.5 and the circular scale is 12 is there, so 0.12, so you got 2.62. Okay. I want to tell you something. You have red chat at the side, the red chat. Okay, the red chat, the final knob to the right. What is the function of that? Red chat.
To make sure that
Perfect pressure to the object.
yes,
To give enough pressure to the object. So
it ticks.
yeah, when you put object, you use the thimble first, rotate it. When it's a little tight, then you use the red chat. If the red chat is like give a one tick sound, is enough. That means the pressure is enough. Don't turn the thimble again. If you change the thimble, then you are not measuring the diameter, but you are deforming the object. Okay, so red chat is important to give the proper pressure. One tick sound is enough. Okay. Okay, so now your turn. Get me the reading. What is your main scale reading? What is your what do you call vernier scale? Main scale how much?
3.
Main scale is 3. Vernier scale?
0.9.
Yes, 0.09. Oh yeah. Okay. All of it. It's 3 and 0.09. So all in mm. You get what? 3.09 mm. 0.09 mm. Okay, good. So we go to the next one. Okay, another one for you. Come on, get the reading.
Five.
5.80.
5.8. 5.80. Basically, it's 5.5. Okay, yeah. So 5.5. So 5.80. Okay, all of you got 5.80. Don't write 5.8. It's 5.80. Never put the zero. You're going to lose mark. Although how accurate you are. Okay. Okay. Next. Okay, this one. So it's going to be 3.5 or 6 and 3.96 mm. Okay. So I believe you can get the reading from micrometer screw gauge. Now we go to the zero error. Okay. Zero error. Oh, sorry. This is another reading. What's the reading again? So this is 3.5. Then 0.06. So 3.56 mm. Micrometer mm. Vernier caliper centimeter. Okay. Okay. Recall back your zero error. So if the zero is perfectly at the center, then no zero error. The first diagram. If the zero without any object, if the zero is went down, the vernier zero is went down, that we call it as a positive zero error. The reading above is positive. Reading above zero is positive. Reading below zero is negative. The reading is above zero. It's about positive 0.02 mm. If the zeros went up, it's a negative reading. 1, 2, 3. What? 1, 2, 3, 4 is negative 0.04 mm. Zero error. Remember how to get the actual reading? Measurement minus zero error. If zero error negative, you just put negative 0.04. So finally, it will be added. Always measurement minus zero error is your final reading. Okay. Okay, now go to the next. Now your measurement must be together with zero error. Okay, we go to the next slide. Sorry. Oh, next slide. Very good idea. So 0 below positive, 0 above negative. Okay, always minus zero error. Okay, so far any questions about these three instruments? This is the most common one you're going to use in exam in your thing. Okay, so after the length, we're going to proceed with other measurements. If involving water, you're going to use measuring cylinder. Measuring cylinder, you measure across milliliter. 1 milliliter is 1 centimeter cube. Okay. Instrument used, measuring cylinder, the accuracy is half of the smaller scale. Please look at the lifeline. Half of the smaller scale. All analog scale, the uncertainty is half of the smaller scale. Half of the smaller scale to determine how many decimal place to write. Okay. Ruler, half of the smaller scale, 0.05. Because 2 places are uncertain, it becomes 0.1. Vernier caliper, half of the smaller scale is 0.01 cm. If 10 interval, for the case of 10 interval, half of the smaller scale is 0.005 cm. Because 2 places are uncertain, it becomes 0.01 cm for 10 interval. Okay. So any analog scale, you have scale, the uncertainty is always half of the smaller scale. Okay, you see the two measuring cylinder at the side here, right? Can you tell me, let's say you measure exactly 10 mm by using the longer measuring cylinder. The second one, the first one on my left, on the left in the diagram. Can you tell me, it's exactly 10 ml. How are you going to write the reading? 10 ml, 10.0 ml, or 10.00 ml?
10.0.
10.0 ml. So why you go for one decimal place? So you check half of the smaller scale. Smaller scale, how much? Smaller scale is 0.1.
1.
Yeah, smaller scale is 1. So half of the smaller scale is 0.0.
0.5.
0.5, sorry, I made a mistake, 0.5. So you go for one decimal place. So by using the first measuring cylinder on the left, you must write 10.0 ml. If those who write 10.10 ml, wrong. Okay. Let's say you measure by using the second cylinder, the first cylinder, the smaller one on my right. Let's say it's exactly give 10 ml. How many decimal place you write? This is quite small.
10.00.
Very good. You must write 10.00 ml. Okay. So follow what? Half of the smallest scale. Okay. So measuring cylinder, when you read, please be careful. Use the reading at the eye level. Try to avoid parallax error. Okay. Try to avoid parallax error. Yeah. Another 2 slides we stop today. Okay, so you see this measuring cylinder, 3 different types of measuring cylinder. Okay, the first measuring cylinder, smaller division is found to be 1 ml. So uncertainty is 0.5 ml. 0.5 ml. So the reading all you must read one decimal place. 9.5, 10.0, 10.5. Okay. Second measuring cylinder, the smallest division is found to be how much? 2 ml. So uncertainty, half of the smaller scale, 2 divided by 2 is 1 ml. So no decimal place. So you must write 9, 10, 11. Don't write 0.0. If you write one decimal place, it's wrong. Okay. The last one, the burette. What is the smallest division? 0.1 ml. Half of the 0.1 ml is 0.05. All the reading must be 2 decimal places. This is very important for you. Cambridge, just look for decimal place. Okay. Let's say a solution given, one student measured 10 ml, another student measured 12 ml, but the reading is supposed to be 10 ml. Okay. The one wrote 10 ml, write the proper decimal place. The one, let's say the actual answer is 10 ml. The one got 10 ml, put a wrong decimal place. The one got 12 ml, put a correct decimal place. Who get correct? Who get mark? 10 or 12? The Cambridge will decide to give mark for 12 ml because correct decimal place. They're going to check the decimal place. A small variation in the reading is fine. Okay, but decimal place wrong means you are wrong because you don't know how to read the instrument precision. Okay, that's the main problem. Okay. Okay, so we stop here. We stop up to measuring cylinder. Okay. So tomorrow we will be continuing with this. You're going to have more instruments. You can read through. You can protector and so on. After protector, we will go to the other instruments. We will discuss tomorrow. Any question for today? Anyone have any questions? No questions. So any analog instrument, how many decimal place you write, it depends to the half of the smallest scale. Ruler, 2 places uncertain, therefore become smaller scale. Half become smaller scale. Vernier caliper, 2 places uncertain, also it become smaller scale, the uncertainty. Micrometer screw gauge also, because 2 places uncertain, become smaller scale. Okay, from measuring cylinder, only 1 place uncertain, you go for half of the smaller scale. Okay, so that's the today's lesson. So if you don't have questions, then I see you tomorrow.
Okay.
Okay, see you then. Bye.